So today we'll be looking at how to prove the expectation of Bernoulli distribution and the variance of Bernoulli distribution. Okay, I want to find or prove the expectation of Bernoulli distribution and the variance of Bernoulli distribution. So first of all, we need to recall that the PMF, that's probability mass function of a Bernoulli distribution, is giving us p raised to power x into bracket 1 minus p raised to power 1 minus x. And that's for the values of x is equals to 0 or 1. Also, it can be written as p of x is equals to p raised to power x q raised to power 1 minus x. That is when where q is equals to 1 minus p. And this is coming from the fact that p plus q is equals to 1. That's probability of success plus probability of failure is equals to 1. And now we know that Bernoulli distribution is coming from a trial or an event that have two possible outcomes. So let's go and find the expectation of x of Bernoulli distribution, given that it is discrete. You remember that it's discrete distribution, and so it will be summation for all values of x p of x. This is the general formula for discrete distribution. The expectation of x is summation for all values of x p of x, and so this will give us expectation of x is simply equals to summation for x is equals to 0, that's starting from this range to 1 of x, then p of x. If you use the second formula, which is the easiest one, p raised to power x q raised to power 1 minus x. So all we need to do is to evaluate this. So if we evaluate for x is equals to 0, put 0 here, we have 0. When x is 0, 0 times p raised to power 0 times q raised to power 1 minus 0. Then plus, when s is 1, of 1 times p raised to power 1 times q raised to power 1 minus 1. Remember, 0 is multiplying. Anything multiplied by 0 give us 0. So this will now be 1 times p raised to power 1, that's p, times q raised to power 1 minus 1, that's 0. Anything raised to power 0 is 1, this is p times 1. And so p times 1 is p. So expectation of Bernoulli distribution is p. That is the probability of success. That's our expectation. Okay? Then we will look for the variance. Variance of x can be obtained. It's the sense of expectation of x squared minus bracket of expectation of x, then all square. This is variance of x. Okay, now we know this already, which is p. Let's get expectation of x squared. So expectation of x squared given the same Bernoulli will be summation for all values of x squared p of x, the same format. Okay, so this is equals to summation for x is equals to 0 to 1 of x squared, then p raised to power x q raised to power 1 minus x. Evaluate for x is equals to 0, we have 0 square times p raised to power 0 times q raised to power 1 minus 0, then plus 1 square times p raised to power 1 times q raised to power 1 minus 1. So this will give us, now that's simple, 0 square is 0, 0 multiply everything here will give us 0. So we have 1 square is 1 times p raised to power 1 that's P, then times Q raised power 0. Then square this. This will give us P times 1. Anything raised power 0 is 1. So this will now lead us to expectation of S square is equals to P. That's P times 1 is P. Then having said that, we now go to our variance of x. Remember, the formula says expectation of S square minus expectation of x all square. So this will give us expectation of x square is P, then minus expectation of x is P, then we square it. So this is setting as P minus P square, and this is setting as P into bracket 1 minus P. And recall 1 minus P is Q, so this is PQ. So it means a variance of x for a Bernoulli distribution is equals to PQ. So it means, therefore, expectation of x of Bernoulli is P, and the variance of x for Bernoulli is PQ. That's it. See you next time. If you have any distribution you want me to prove for you, send it in the comment section below. Thank you.